Hi students, welcome to the physics session of Narayan PU College. So today onwards we are starting new lesson. That is second lesson for us. So units and so name of the lesson is units and measurements. So what is unit? What is measurement? In this lesson we are going to discuss. First of all, who will be having this measurement? Who will be having this unit? Who means not person here. So which one is having measurement? Which one is having unit? So we should discuss that first before going to start the lesson. So who will be having unit and measurement? Generally what you will measure? What you will measure means, let us assume. So length of this chalk piece. So length of the chalk piece means we are measuring length. Here what is length? We should come from. So like that, mass of this chalk piece. Okay. So mass of the chalk piece we are going to measure. Okay. So mass is what? Means mass is what? Means what we are going to call mass. So length, mass, like that. If you are taking like this, height of this chalk piece or radius of this chalk piece. What are all these in LHS? Radius, length, mass, velocity, speed. All these are, we are calling it as physical quantity. First we should come to know what is meant by physical quantity. We will be having so many physical quantities. Already you heard, you came to know, but you don't know that one we are calling physical quantity. Okay, so now I told you length of this chalk piece. Now here length is called physical quantity. Mass of the chalk piece. Mass we are calling it as physical quantity. So what is the definition of physical quantity and how many physical quantities are there? Now this physical quantity we are going to measure. While measuring physical quantity, we are representing with units. Okay. So for measurement and unit, base is this one. Okay. What is now physical quantity? What is the definition of physical quantity? So already I gave this definition whenever we were discussing motion in a straight line. Somewhere we got relation for scalars and vectors, distance displacement. At the time, so just I gave a definition. Now clearly we are going to discuss how many types of physical quantities are there, how the units and measurements came. All these we are going to discuss. Why we are starting this lesson? Even though it is second lesson, we are starting as third lesson. Why we are starting means we should come to know some physical quantities. Therefore, we are starting now. So what is meant by physical quantity? So the quantity which is measured. The quantity which can be measurable or which is measured is called physical quantity. So what is measured? Let us assume mass of this chalk piece or length of this chalk. Can we measure length of this chalk piece? We can measure length of the chalk piece. Therefore, length is a physical quantity. So can we measure mass of this chalk piece? We can measure mass of the chalk piece. Therefore, mass is a physical quantity. So what are the examples for physical quantities? So what are the examples here? So you can take so many physical quantities. That is nothing but here what I gave, length. So mass. So length, mass, like that. What you can measure? Height you can measure. Height is also physical quantity. Radius also physical quantity. Depth is also physical quantity. So volume is also physical quantity. So you will be coming to know velocity. This is also physical quantity. Acceleration. This is also physical quantity. Force. That is also physical quantity. So all these are physical quantities and all these can be measurable. All these physical quantities can be measurable. So therefore weight, all these you can take. So all these are, we are calling it as physical quantities. So now what is the definition of physical quantity? The quantity which can be measured is called physical quantity. Now depending on physical quantities, there are two types of physical physical quantities. One is, how many types of physical quantities? Two types. So number one, first physical quantity we are calling it as fundamental physical quantity. So first one is fundamental physical quantity. For shortcut they will write like this, F, P, Q. So whenever I am writing next time I will write F, P, Q. Here F refers fundamental physical quantity. Second one, how many types of physical quantities are there? Two types. So first one is fundamental physical quantity. Next one is derived physical quantity, DPQ. So fundamental physical quantity, derived physical quantity. How many types of physical quantities are there? Two types of physical quantities are there. This is just introduction for the lesson because we want units and measurements. First we are going to discuss about unit. We will be having unit which can be measurement, which is having measurement, means physical quantities. Therefore, this is the origin for this lesson. Now derived physical quantity, fundamental physical quantity. Now which will be coming under fundamental physical quantities, which will be coming under derived physical quantities. So I gave here length, mass, volume, velocity, acceleration, force. Some physical quantities I gave. Among all those, which are fundamental, which are derived. For this, you should come to know definition of fundamental physical quantity. So what is definition? So definition of FPQ. So all of you should write this one, physical quantity definition. So the quantity which can be measured or which is measured. Next, there are two types of physical quantities. These are examples for physical quantities. So there are two types of physical quantities. One is fundamental physical quantity, another one is derived physical quantity. Now I am giving definition for fundamental physical quantity. So what is the fundamental physical quantity? Means the quantity or the physical quantity which cannot depend on any other physical quantity. Okay? So the physical quantity which cannot depend on any other physical quantity. So the physical quantity or the quantity which cannot depend on any other physical quantity. So it should not depend on other physical quantities. This is the definition. I will give you an example. Second one, so definition of derived physical quantity. This one you can only say. So the physical quantity which cannot depend on other physical quantity, we are calling it as fundamental. Fundamental means base. That one also they will say base physical quantity. Another name of this one. Fundamental or base. Basic they will say like that. Next, derived physical quantity. So the physical quantity which depends on fundamental physical quantity. So the physical quantity which depends on fundamental physical quantity is called derived physical quantity. Okay. So how many fundamental physical quantities are there? How many derived physical quantities are there? We will give examples. Now, this is the definition. I think all of you understood. The physical quantity which cannot depend on any other physical quantity. So the physical quantity which depends on fundamental physical quantity. So in your home, your parents are there. Your parents are not depending on any other. Okay. So therefore, your parents we are calling it as fundamental physical quantities. You will be depending on your parents. Therefore, you are dependents. Therefore, you are calling it as derived physical quantity. Now I gave definition. I hope all of you understood. So it depends means derived, does not depend means fundamental. So there are, so first one, fundamental physical quantities. So there are 7 fundamental physical quantities. So what are those? How many fundamental physical quantities are there? 7 fundamental physical quantities. So what are those? We will see. So first one, length. Okay, length is fundamental physical quantity. If you are going to measure length means it will not depend on anything. Length of this chalk piece, it is depending on only length. It does not depend on any other physical quantity. So next, mass. So mass also individually it will be there. So it will not depend on any other physical quantity. So third one, time. So length, mass, time. Fourth one, temperature. Fifth one, current. Current means electric current. Sixth one, amount of substance. Seventh one, luminous intensity. So all these are fundamental physical quantities. So first one, length. Length does not depend on any other physical quantity, like that mass, time. Time is also not depending on any other physical quantity. Temperature. So whether it is hot or coldness. What is temperature definition means? The degree of hotness or coldness. That is nothing but temperature. Already you heard this one so many times. So water is very hot, they will say. Means it is having more temperature. Cold means ice is at 0 degrees Celsius. Cold means less temperature. So what is room temperature? 27 degrees or 30 degrees Celsius depending on the situation. Current. So this temperature in our book they might have written thermodynamic temperature or temperature. Both will be same only. Next, current. Electric current or current they will say. So generally you will be coming to know, so current means to any electrical appliance, this current is going to be supplied. Therefore, this current is fundamental physical quantity. Next, amount of substance. So what is mass definition we will be coming to know. So what is mass definition means? We will say the amount of matter contained in the body, or simply we will say amount of substance. What is the mass of this substance means how much substance it will be there, how much matter it contains. Then here also we say amount of substance. What is the difference? I will say luminous intensity. So it will be coming for optics case, luminous intensity. So in textbook they gave definitions for all these. I am going to give definition of this one only. Actually definition is not required for you. In case of exam, you don't need to write anywhere. Only one definition I will give for you people to understand. So remembering, presently not required for exam, so not required to write also. Okay, but symbols and all this you have to write. But still we did start unit and measurement. Just I am giving basics, and these are also very important for lesson in that lesson. Okay. So all these 7 we are calling it as fundamental physical quantity. Now I told you, so mass and the amount of substance. Why we require? Because both are same only. Mass is nothing but the amount of matter or substance. The amount of substance means that is also mass only. Then why we gave these two as two different physical quantities? So why we gave means, here mass means mass of human body. We will say 50 kg. So mass of duster. Okay. So we will say 2 grams, 3 grams. But below grams, 2 grams, milligrams will be there, micrograms will be there. So mass of electron, mass of proton, all those values will be very less. So where we will use amount of substance means for gas molecules, we are going to use amount of substance. Why? Because gas molecules mass is very less, into 10 power minus 30 minus 27, like that it will be there. So what is the 10 power minus 27 minus 37? Whenever we are giving values, I am going to explain for you. So first we have to understand where we are going to use mass, where we are going to use amount of substance. Mass will be used for which is having more kg, means 1 kg, 2 kg, 3 kg. More mass is there. Here less mass is there. Less mass is nothing but gas molecules. Like the cotton if we have taken, like the gas molecules will be having very less amount of mass. Means they will be moving on the air only. They will not touch the ground. Okay. So that type of substances are means gas molecules are there, means we will take the amount of substance. All these are not depending on any other physical quantities. Now we will see there are how many fundamental physical quantities now? 7 fundamental physical quantities. Now we will see derived physical quantity. Second one, derived physical quantity. Examples. So except this, whatever we have taken, all those will be coming under derived physical quantities. We will see. So before going to see this length, very important one. First fundamental physical quantity, length. If they gave height, if they gave breadth, if they gave thickness, if they are going to measure radius, if they are going to measure diameter. So all these will be coming under length only. Length is different, radius is different, because radius 2 meters will be said, isn't it? So length 2 meters. So length of this chalk piece 5 centimeters, isn't it? So therefore radius, length, height, displacement, distance, all these will be coming under fundamental physical quantity. So derived physical quantity, can you write distance here? You cannot write distance, because the distance will be going to the length. Displacement also going to the length. Therefore, distance displacements are not derived physical quantities. Those are fundamental physical quantities, because it will be coming under length. Okay, please remember that. Now, what will be coming under derived physical quantity? So, which quantities you came to know in first means motion in a straight line and motion in a plane? Just I am writing speed. So speed is derived physical quantity. Why speed is derived physical quantity means, now speed is depending on two fundamental physical quantities. What is the speed definition we will say? The rate of change of distance or distance by time. What is speed definition? Distance by time. Now what is distance? Distance will be going for length. Time is going for time here. This is nothing but these two are fundamental physical quantities. Therefore, speed is now depending on two fundamental physical quantities. Therefore, speed is, we are calling it as derived physical quantity. I hope you understood now, according to definition, how these are going to be variation. Okay. Now, speed is derived physical quantity. If I wrote velocity, now what is velocity? So velocity is nothing but displacement by time. Again, displacement will be going for fundamental physical quantity. Time is going for fundamental physical quantity. Therefore, velocity is coming under derived physical quantities. Except these 7, remaining all, you will be almost you are getting for derived physical quantity. If you have taken acceleration, the acceleration means what is the definition? Rate of change of velocity. Velocity by time. Isn't it? Acceleration. Velocity by time. Again, velocity is displacement by time into time. Now again, acceleration is depending on two fundamental physical quantities. Therefore, acceleration is called derived physical quantity. So length, mass, fundamental. Now volume. Velocity is derived. Acceleration is derived. We will see what is volume, what is force. Volume means, generally we will be coming to know. Volume means, what is the formula? LQ, or length into breadth into height. So volume is equal to LBH. They will write. Now length, breadth, height. What I told you, length, breadth, height will be coming under fundamental physical quantity. Not only length, breadth also some length only. Height also some length only. Therefore, all these will be coming under fundamental physical quantities. Now, volume is depending on fundamental physical quantity. Therefore, volume we are calling it as derived physical quantity. So, volume. Another one is here, force is there. What is force equation? Force we came to know, F is equal to MA. Somewhere in your 10th class or 9th class you saw that equation, MA. Now, force is depending on mass. Now, mass is which quantity? Fundamental physical quantity. Now, only we said acceleration. If you write acceleration like this, you will be getting velocity by time, displacement. Again, acceleration is depending on length and time. Therefore, again, two fundamental physical quantities. Therefore, force is depending on fundamental physical quantities. Therefore, force we are calling it as derived physical quantities. Like that, we can write so many derived physical quantities example, but fundamental physical quantities only 7 are there. These are nothing but very, very important. So you will be remembering well length, mass, time, temperature well. Why? Because these 4 you will be getting in first PU. Even amount of substance also you will get. But current and luminous intensity you won't get in first PU. But you have to remember extra current and luminous intensity. Length, mass, time, temperature, electric current, amount of substance, luminous intensity. All these 7 are called fundamental physical quantities. Remaining all almost you will be getting derived physical quantities except 2 quantities. Those we are calling it as supplementary quantities. Later we will be getting means angle. Okay, solid angle and angle you will be getting. So those we will discuss. We are going to discuss now only. So now this is about physical quantity definition. How many types of physical quantities are there? So those definitions and fundamental physical quantity, derived physical quantities, and you have to write all these. And I hope you understood well. Now we are going into the original lesson. So now we are going to discuss about units. So what is meant by unit first? You know so many units: meter, centimeter, second, mass unit, kg, gram. All these you came to know. That is unit. The definition we are going to give. How it is coming. So what is the definition of unit means? The measurement. So measurement of any physical quantity. So simply you can remember this statement. The measurement of any physical quantity. Okay. So what is going to measure? Let us assume, take one example. Length of this chalk piece. So length of this chalk piece L is equal to, here L means length of the chalk piece. I am taking this chalk piece length, I kept on meter scale. Let us assume you got 10. After writing 10, you will write one unit here. Okay. So 10 generally you will be coming to know centimeters, because whenever we are taking scale, we are going to take centimeters or millimeters. If you have taken small scale, 15 centimeter scale, you got, let us assume, 10 centimeters. Now this is called unit, isn't it? Now what is this 10? What is this 10 means? Measurement. So 10 is the measurement of which physical quantity? Length. This is simple. So what is meant by unit means? This measurement of this physical quantity. This is the general definition of unit. But after this, in our textbook, it will extend. How it is extended means which involves comparison of arbitrarily chosen standard system of units derivatives. Internationally accepted standard is called unit derivatives. So if you wrote that one, or if you didn't write that one, no problem. Why? Because so whenever we are taking length is 10 centimeters, convert this one into millimeters. L is equal to 10 centimeters. So 1 centimeter is having how many millimeters? 1 centimeter is equal to how many millimeters? 10 millimeters is equal to 1 centimeter we will take. Like 1 meter is equal to how many centimeters? 100 centimeters. Like that 1 meter is equal to 100 into 10 millimeters. Isn't it? 1000 millimeters. 1000 millimeters is called 1 meter. 100 centimeters is equal to 1 meter. 1 centimeter is equal to 10 millimeters. Correct only? So substitute here. So 10 into centimeters I am converting into millimeters. Then what you want? 100 millimeters. Same length is same only. 10 centimeters, 100 millimeters. Both will be same one. Now write the centimeters or millimeters into meters. Convert into meters. Because all this you came to know. But still, identity for you centimeter when you have to take, millimeter when you have to take, meter when you have to take. Okay. So millimeters into meters. So 1 meter is equal to what I said, 1000 millimeters. Then 1 millimeter is equal. This 1000 will come this side. 1 by 1000. Therefore, 10 into 1 by 1000 meters. Correct on this one? This 1000 is coming here. 1 by 1000 meters is equal to 1 millimeter. So 2 zeros you can cancel. Then 1 by 10 meters. 1 by 10 is nothing but 0.1 meter. Now see here. I am saying about after this what they give the definition, which involves comparison, arbitrarily chosen, and internationally accepted standard is called unit derivative. If you wrote like this also, that is correct. So why they give the statement and length? Now length is equal to how much you got now? Initially we got 10 in centimeters. In millimeters you got 100 in millimeters. In meters, you got 0.1 meter. Here, physical quantity is same, but depending on this unit, these values are going to be changed. Now, among all these, which is bigger unit? Meter, centimeter, or millimeter? Which is bigger unit? First one is bigger unit is meter. Next bigger unit is centimeter. Next bigger unit is smaller unit is millimeter. This is the meter, centimeter, millimeter. So for bigger unit you got which value? Smaller value. Which is smaller value among all this? 0.1. I am saying value, that is called measurement. Which is smaller measurement? 0.1. Which is bigger unit? Meter. Means bigger unit is giving smaller measurement. Okay. So meter is giving only 0.1. Centimeter is giving 100. Millimeter is giving 12. Centimeter is giving 10. Millimeter is giving 100. Means if you are increasing the unit, increasing the unit means millimeter to centimeter, centimeter to meter. So what happens to the value? You can see if you are increasing the unit value, what is happening? 100 is going to become 10, 10 is going to become 0.1. This is nothing but value. What happens to the value? It is going to decrease. Correct only? Millimeter to meter. Unit is increasing, value is decreasing. Therefore, this measurement value is depending on this unit. Okay, how we are writing this one means this is one numerical value n1. This is one unit u1. This will be important for competitive. They won't ask you n1 u1. This is one value n2. This is one unit u2, n3 u3. So all these are equal to one physical quantity. That is nothing but constant. This one only they will write. How they will write means in your 10th class Boyle's law you can know. P1 V1 is equal to P2 V2. How they will write? PV is equal to constant. Then P is inversely proportional to volume. Isn't it? So same like that. Here N1 V1 equal to N2 V2 equal to N3 U3. Therefore Nu is equal to constant. What is N here? Numerical value or measurement. What is U here? Unit. So numerical value and unit product is always constant. Therefore, we will write N is inversely proportional to U. So this one only not. If unit is increasing, numerical value is decreasing. If unit is increasing, numerical value is decreasing. Isn't it? So this is nothing but very important relation. This won't be available in the textbook, but very important for competitive purpose. So this is the unit definition. What is unit definition? Measurement of any physical quantity. So which involves in comparison. Comparison means centimeters, millimeters, meters. Arbitrarily chosen means what we have chosen depending on the situation it is going to be chosen. And systematic means internationally accepted standard. What is internationally accepted standard means? We will say now system of units. SI units we will say. What is that SI unit means? So that unit is accepted internationally. International means wherever you go, if you say second means, so in America or India, whichever country if you said second means I said about time. Okay, if you go for America, we will say here mass means kg. They will say in pounds. I think you may see WW. So in that, whenever they are coming outside, their mass they will say 200 pounds, 400 pounds they will say. Pounds means they are representing their mass or weight. Okay, so that is going to be changed depending on the country. Internationally accepted means if I say kg, wherever you say, whichever country you went and say kg means he said about mass. If I say second, then he said about time, like that. So that unit we are calling it as system of internationally accepted unit. The units I am going to give for you. Already you came to know CGS, MKS, FPS. All those I am going to give for. Okay, this formula is important for only competitive, not required for PU. Okay, if unit is increasing, numerical value is decreasing. So this is the definition of unit. And different types of units we will see now. So a system of internationally accepted units. So one is CGS, another one is MKS, another one is FPS. So you have very well about CGS, MKS. I think you came to know FPS or not, I don't know. So I will give these. These are nothing but units, different types of units. So before going to that one, here how many types of units will be there? Because how many types of, because unit is depending on measurement of physical quantity. Now how many types of physical quantities are there? Two types. One is fundamental physical quantity, or they will say base physical quantity. Second one, derived physical quantity. That one is DPQ, derived physical quantity. Now measurement of physical quantity. If it is here fundamental physical quantity, that unit we are calling it as fundamental unit or base unit. The unit which is representing fundamental physical quantity, that unit we are calling it as fundamental unit. The unit which is representing derived physical quantity, that unit we are calling it as derived physical quantity. So system of internationally accepted unit means in that both fundamental units and derived units will be present. So fundamental physical quantities means which does not depend on any other physical quantity. Fundamental unit means the unit of fundamental physical quantities are called fundamental units or base units. So those are having different types: CGS, MKS, FPS. This is system of units. So for this, they will give length, mass, time. Okay. So CGS, length means it will be starting with C, that is nothing but centimeter. So cm. How to write units also I will say. So some people will write centimeter means capital C, like this they will. So you should not write centimeter like this. You have to write always centimeter, small letters now. Centimeter you have to write. Whenever we can't write always centimeter, they will write simply cm. Small c, small. In cm also you should not write like this. cm. Okay, centimeter. You should not write like this. You should write this. This is called lazy unit, we will say. Lazy unit means there is not any particular definition, because we can't write centimeter fully always. Therefore, in physics they will write cm centimeter. So mass means what G refers here. So CGS, centimeter. G refers gram. So gram fully if you want to write means GRAM. Lazy unit is GM, we will write, very simple. So this S refers time. Time means second. If you are not able to write means lazy unit, simply we will write yes. Next, MKS. MKS means it is starting with M. Length. Length means it is nothing but meter. So METER, or simply we will write M. K. So mass. We will write here K means kg. This K also should be small letter. Okay. So kilogram. Instead of writing kilogram, we will write kg. Second. Again, yes one. Next, FPS. This is British system, they will say, so we won't follow this one very well. But you have this one. What is F refers here means food. Foods. P refers pounds. S refers again second. If you go for British or anywhere British country also, if you say second means that is time. But they will measure mass in pounds. They will measure length in foots. 1 foot, 2 foots, 3 foots, like that. So these conversions also will be there for you. Mainly we will follow CGS and MKS. So any problem we are giving in physics means they will do all problems in MKS system. Okay, in MKS system or simply they will say SI system. So all these are different types of units. So now we gave unit definition. So measurement of any physical quantity. So depending on physical quantities, there are two types of units are there. One is fundamental unit, another one is derived unit. The unit of fundamental physical quantity is called fundamental unit or base unit. The unit of derived physical quantity is called derived unit. Next, different types of accepted system of units: CGS, MKS, FPS. Okay, length means centimeter, meter, foot. So this system we won't use regularly, only these two we are going to use more. Okay. So now we saw CGS, MKS, FPS system of units. Now we will see So what are fundamental units? Because fundamental physical quantities already you came to know. So what are those fundamental physical quantities? First one is length. Second one is mass. So time, temperature, so current, so amount of substance, and last one luminous intensity. Okay, so these are the different fundamental physical quantities. For these symbols and units and unit symbols will be there. That is nothing but system of internationally accepted units. So length unit now only we said. So in SI system, that is nothing but MK system, they will say meter. So meter means we will write M. Means I am saying only symbol of unit. I told you how to write also. So meter means capital M, you should not write like this. You should not write. You should not write like this. You should write like this. With these definitions also they give. Definitions are not required for you, but these will be coming continuously for you. Because mass, time you came to know, but remaining you should come to know first. So mass means you came to know kilogram. Kilogram means we will write kg. Time we came to know second, small s. What is temperature? Now can anybody say what is temperature? It means, so we will say either degree Celsius or Kelvin. Therefore Kelvin means small k they are. If you want to write fully, Kelvin. Current you will be coming to know ampere. This one they will write capital A. Amount of substance. Amount of substance means they will say moles. Moles is the unit. While writing, we will write MOL. So small letters MOL. Next, luminous intensity. They will say unit name is candela. Because these are new units for you. Therefore, I am writing. Candela means in shortcut. Lazy unit is CD. Okay, ampere also you might have heard so many times. Okay, current units amperes. Amount of substance moles. Moles means they will write MOL. Next, luminous intensity candela we will write C. So they give definition of length. 1 meter they will define. What is 1 meter means? The distance traveled by the light in vacuum. Vacuum means no space or free space. The distance traveled by light in vacuum in a time interval of this much. 299, 792, 458 of second. So in the time of 1 by 299, 792, 458. You can pronounce this one 299 lakhs 792,458. So that is your wish. So you no need to remember this value also, this definition also. Just time period. So what is this much? 1 by this much means. Half second means 1 by 2 seconds. Isn't it? 1 by 2. 1 by 10 second. Like that, 1 by this much number means it will be coming if you do with calculator 0.0000 like that. So in that fraction of seconds, the distance traveled by the light in vacuum, how much distance it is traveling, that fundamental distance we are calling it as meter. And they give remaining definitions also. So all these not required for you. This ampere definition we are going to give in second PU for you. At the time, this is important. Now if you said also you can't understand. Now only I said meter means small letters we have to use, but here we wrote capital letter. Okay. In second PU some units we will write capital letters to represent the differentiation between what we are writing means which physical quantity we are representing. But whenever I wrote here ampere, I didn't write capital A here. Okay. So ampere is I wrote small a only, but simple. So they are representing like this. Okay. In second year, some units we will represent with capital letters. This is second year concept, current concept. You will be getting that. So this amount of substance you will be getting in first period. So this luminous intensity you will get in second period, but you can't see this one in second period. But optics we will discuss. So now these units, 7 units are called fundamental units. Why we are calling it as fundamental units? Because these units are units of fundamental physical quantities. Now, how many fundamental physical quantities are there? 7 fundamental physical quantities. How many fundamental units are there? 7 fundamental units. Okay. Now, in addition to this, I told you, so which does not depend on any other physical quantity, those are called fundamental physical quantities. Which are depending on physical quantities. The quantities which are depending on physical quantities means fundamental physical quantities. We are calling it as derived physical quantities. Some quantities neither depend on fundamental, so those are also independent. So those are not depending on fundamental physical quantities. So those quantities we are calling it as supplementary quantities. Supplementary quantities. So what are those? Supplementary quantities. You will write supplementary exam. If you fail in main exam, they will write supplementary. Same like that. So those will not be coming under fundamental physical quantities. But I told you derived physical quantities depending on fundamental physical quantities. But these quantities neither depends on fundamental nor depend on derived. Therefore, these quantities we are calling it as supplementary quantities. They didn't give definition of these for you, but they gave supplementary units they gave. So these are coming under fundamental units or base units. Now these two units are coming under supplementary units. So what are supplementary units means? The units of supplementary physical quantities are called supplementary units. What are those supplementary quantities? So one is plane angle. Number 1. Number 2 is solid angle. It is denoted with theta or d theta. It is denoted with ohm. So d ohm. Where you will see this ohm means resistance units. Ohm they will write. So that symbol d ohm they will write or ohm. So this is nothing but solid angle, plane angle. So plane angle and solid angles will be coming under which quantities? Supplementary quantities. What is the unit of this one? This is nothing but radian. RAD they will write. So this one is steradian. So this is radian. Symbol is RAD. Steradian they will write SR. Small s small. So steradian, radian. These two are known as supplementary units. Plane angle, solid angle are known as supplementary quantities. Now, how they will define? Already you came to know this angle definition. What is angle definition? Theta is equal to angle theta is equal to arc length by radius. In mathematics also you got. I also explained in motion in straight line lesson. Whenever object is moving in circular path, theta definition arc length by radius. If you have taken any plane, this circle. So this length between A to B. So this angle we are calling it as theta. This theta is nothing but this arc length by this radius. L by R. In our textbook they give this L as ds. ds by R. The ratio between arc length and radius is called plane angle. Next, what is solid angle? Who will get solid angle means this single plane, just one circle. Circle means like bangle. Bangle will be having which angle means plane angle. If you have taken a rubber ball, so rubber ball means solid ball like this. If you have taken means further you will get solid angle. If you have taken a rubber ball like this, small area you can take. So it is going to be rounded like this. Small area you can take. So this is rubber ball. Ball means it will be like spherical shape. Spherical shape is different. Circular shape is different. Bangle is under circular shape. So ball is under spherical shape. For this small area I am going to take. Now this angle is called which angle? Solid angle. How they will define this? d ohm is equal to this surface area. That is nothing but dA. So dA by r square. The ratio between how much area it is going to be subtended. This angle we are calling how much angle subtends. You will get this word subtend word in mathematics. How much angle subtended by the intersected or intercepted area. So dA. So this area and square of the radius. Square of the radius means r square. This ratio we are calling it as what we are calling? solid angle. So this is called stereo. So these are having units. Okay, radian, stereo. Now later we are going to discuss about dimensions, but these are not having dimensions. And then there we will discuss why it is not having dimensions. But presently, so supplementary quantities are two. So supplementary units are plane angle, solid angle, radian, stereo. So the ratio between arc length and radius is called plane angle. The ratio between intercepted area and sphere of the radius is called solid angle. Okay. So now, up to now we discussed fundamental physical quantities, fundamental units. There are 7 fundamental physical quantities, 7 fundamental units or base units. Now 2 supplementary quantities, 2 supplementary units. Next we will be having actually derived physical quantities. Derived physical quantities means derived units will be there. Yes, derived units will be there, but those so many will be there, they didn't give in our textbook. So each and every unit other than fundamental unit will be coming under derived unit, except for supplementary units. So generally we will say speed. What we will say speed units? Meter per second. So meter per second means, now this unit we are calling it as which unit? Derived unit. Like that, acceleration, meter per second square. Acceleration unit, meter per second square. So meter per second square is also derived unit. Okay, remaining all except the 7 fundamental and the 2 supplementary units, remaining all units will be coming under these. Which one? Derived units. Next. Our next topic is measurement of length. How we are going to measure the length? You came to know very well meter scale or centimeter scale we will say. Means, so in our compass box or geometry box, 15 centimeter scale will be there. Isn't it? Generally 1 meter scale also will be there. So by using scale, normal scale, we are going to measure the length. Okay. By using normal scale. In addition to this, 2 apparatus or instruments will be there. What are those means? Vernier calipers. So what is vernier calipers means? We will be seeing in lab this one. By this, what we are going to measure means we can measure presently length and screw gauge and a speedometer. So all these are instrument or apparatus to measure the length. But all of you will be coming to know this scale. So from where to where you can measure the length? By using this scale, minimum we can find 1 millimeter. I am saying geometry box scale. Maximum we can measure up to 15 centimeters. This is 15 centimeter scale can measure from 1 millimeter to 15 centimeters. Generally, normal scale, meter scale if you have taken means. Meter means here 1 mm you can measure least. Last one up to 100 centimeters. 100 centimeters means 1 mm to 10 square centimeters. So this one only they will give like this. 1 millimeters means 10 power minus 3 meters. 1 millimeter. Already I wrote this one after converting 1 by 1000. 1 by 1000 you can write it as 1 by 10 cube. 1 by 10 cube means 10 power minus 3. Next up. 10 square centimeters. So this value they gave in our next one, 10 power minus 3 to 10 square meters. 10 square meters means up to 100 meters. So this is the minimum and maximum value of measurement of length by using scale. Like the vernier calipers also will be there, screw gauge and speedometer. So all these values we are going to discuss in our lab. At the time you will be coming to know. So what is this 1 mm we are calling it nothing but least measurement of, by using least measurement of physical quantity by using any apparatus. So So least count they will say. So least measurement is nothing but least count of linear calipers, least count of screw gauge, least count of speedometer. Means how much least value we can measure by using the apparatus. Here scale is nothing but apparatus. Like that, how scale you came to know, this linear calipers is one apparatus to measure length. Like the screw gauge is one apparatus to measure length. Not only length, radius or that one. So speedometer, so height or radius, like that we will measure. Here length means radius, height, depth, breadth, all these will be coming under length only. Okay, so these names will be there in our textbook. These we are going to use in our lab. You will do with your hands all this. At the time you will understand very well. This is measurement of length. How we are going to measure the length. So there are two methods will be there to find the length. One is parallax method, large distance. One is small distance. How we will take large distance? All of you do small experiment before going to end this class. Once you can see any pen or pencil, you can see like this. So this one you can see by closing one eye like this. By closing left eye you can see like this. Later you can close right eye and you can see like this. On wall you can see. Now you can see once this pencil, this chalk piece you can see by closing left eye. So it will be coming somewhere here. Okay, so by closing right eye, if you close left eye, next you have to open, close right eye. So first left eye you can close, later right eye you can close. At the time you will be seeing here. Isn't it? So this point you can see on 2 points on the wall. Whenever you are closing left eye, whenever you are closing right eye. So what is this distance? Distance is called base distance. This distance is nothing but distance between your two eyes. This is called parallax error radius. Means whenever you are seeing with left eye, whenever you are seeing with right eye, this distance is going to be changed. Okay, this method we are calling it as parallax method. By using this, we can find large object distances. Means we can find distance of the earth from the distance of the sun or earth from some point or diameter of the earth. All these we can find. These are means large distance method and small distance method. This method name is parallax method. Okay, what is parallax means? This one. Okay, so this distance between two eyes we are calling it as base distance or base distance we will say. Okay, once you can try this one at your home, you have to see either pen or anything you can take. So on 2 points it is going to be measured. Okay, next class we will see this how to measure large distance and small distance. Okay.